Welcome to I Like to Run Line. I thought that this concept was worthy of a special video, an extra video in our series, the area under the curve. Which curve? The curve made up of the normal probability distribution. So again, this is the particular shape of the normal probability distribution. This could have been the example where we had 100 high school students attempting 10 baskets and making a certain number of these baskets. And then we would want to ask, well, what is the probability that we'll have between 5 and 7 baskets made? Well, the way to do that is to go ahead and graph our probability function. We can do that using the equation that we saw in the previous video. And then we find the area underneath the curve from 5 to 7. Now, how do we do that? Well, we could do that using this equation right here by taking the integral of the function that we saw in the previous video, but we already indicated that would be very difficult to do. So in this case, 5 would be the point A, 7 would be the point B, would integrate over that range that gives us the area underneath the curve. That's how we find area underneath curves, is by taking the definite integral, we integrate the function, and we evaluate it from A to B. If you don't know how to do that, because that's a little beyond this class, then don't worry about it. We will come up with another method to find the area underneath the curve, and thus getting the same result as if we had done the integral. Now, keep in mind that if we take the area underneath the entire curve, that will always equal 1. 1 means 100% probability that we'll get a value from A to B. Of course, A is the smallest value possible, and B is the largest value possible from 0 to 10 in our example. But if we want to find the probability of a smaller range, then we need to just find this particular area underneath the curve. And we're going to show you how to do that effectively without needing to do the difficult calculation. But at least now you have an idea of what that means, finding the probability underneath a distribution, a normal distribution, and it means we're going to find the area under that curve, and that is how it's done. And I think we have one more today.